So I wanted to do an example here about significant figures and why it matters. Consider we have a box. Let's say the box is 21.35 centimeters long. Let's say the box is 3.26 centimeters wide. And let's say that the box is 11.43 centimeters tall. And I want to know the volume of the box. That's pretty simple. Length times width times height. 21.35 times 3.26 times 11.43. Okay, these are all centimeters. So the answer comes out to be, if I multiply everything out, 795.53943 cubic centimeters. But we know our rule for significant figures is we should round to that spot. So that'll be 976 cubic centimeters. Okay, because we have three significant figures is the lowest one. Okay, so we round to that point. Now, why is that the case? Well, let's consider what if we change things? So what if this number was not exactly measured? Remember, this last digit's a guess. So what if that 5 were actually a 4? What would that change? Well, that would change my answer here. My answer would be 795.166,812 cubic centimeters. So when I round it, that would be 795 cubic centimeters. Remember, this is our least significant thing, so that would change by 1. Okay, that doesn't really matter. It doesn't really change a whole lot. So that doesn't change much. You know, put that back. Okay, if I change this right here, if that, however, were instead, if that were a 7, then the answer would have come out to be 797.97935. Well, I mean, again, this number right here is the one that's changing. Okay, so a change in this third decimal spot right there changes here substantially. The last thing didn't change it very much. Now this is changing substantially. So that's why this number right here is the one that we have to round to. So that would be the least significant figure right there. Okay. And so, again, put it back to the original, put everything back to the original, and so 795.53943 cubic centimeters. Okay, we round to that spot right there. 796 cubic centimeters. Okay, so there we have it, 796 cubic centimeters. Significant figures, you should keep track of them. If you write all the way out here, you are implicitly telling someone that you actually know the volume out to that many decimal spots. Okay. Now, why does that matter? Again, most people that take this class want to go into science and engineering. You have to be very precise. If you say something, you have to make sure that what you say is actually correct. And if you give an answer to a lot of digits, you are telling people implicitly that you know the answer to that point. Now, other people may be very particular. It could be that they have an exact measurement, and only a certain thing fits. So they may need to know a volume or a dimension to a certain level. If you give it to that level, you're saying you know it to that level. And if you don't really know it at that level, it might not fit. Now, if you give it to less precision than they need, then they know, oh, wait, okay, this last digit's uncertain, so if I need it more than that, I need to go back and make more measurements. Or I just build in a level of uncertainty or something to compensate for that. But you have to give the answer that they need. Okay, and so significant figures are important. I will take off if you have the significant figures wrong on tests or on homework. So keep track of significant figures from now on throughout the entire semester, and next semester, if you have me for physics 2, I'll also take off for significant figures if you have them wrong. So follow the rules. Now, I give a little bit of leeway if you're off by a little bit, not a big deal. But again, I give leeway on the final answer, because depending on how you rounded the answer when you're doing the calculations, this last digit can be slightly off. And so I give you a range in there. And I give you the range at the level of least significance. So, for sure, keep track of significant figures.